Hello everyone. Now we will move ahead with the production of the lasers. Till now we have studied the basic principles and other related derivations. Now we will see few terminologies in the production of the laser and move ahead with the construction of the laser devices. The first term is the population. So already we have seen what is a population. Population is number of atoms in that energy level or energy state. Both are same. Energy level and energy states are same. So this is the energy level. E1 is the energy level. E2 is the energy level. Okay. The number of atoms over here are N1. Number of atoms in this state are N2. That means population of E1 is N1, population of E2 is N2. In the same way, it may have E3, okay, then E4. There will be so many energy levels. For our purpose, simplicity, we have taken it as only two states, E1 state and E2 state. So there will be many states and particular number of atoms will indicate the population of that particular state. Now we will see what is the population inversion. Population inversion. Okay, the name itself is indicating us something is inverted, right? So let us say there are two energy levels. This is one energy level and this is another energy level, E1, E2. Okay, the number of atoms here are N1 and number of atoms here are N2. Okay, if there are more number of atoms here compared to this, if there are more number of atoms, that means N2 is greater than N1. This condition is called as population inversion condition. Okay, or in the material, if N2 is greater than N1, if this condition is achieved, then we can say that population inversion is achieved in case of that particular material. This is very important in the production of the laser, because if we have more and more numbers in the higher state, we will get more and more laser output. So this is the population inversion case. So we will start with a schematic diagram of the laser. The schematic diagram is like this. We have a cavity. So this is called as a cavity. This is the cavity of the laser, okay, which is fitted with two mirrors. This is one mirror and this is another mirror here. Okay, this mirror is partially polished. This is partially silvered mirror, or even we can use the gold mirror, partially gold or silver mirror. So this is fully polished, fully silvered mirror. Okay. So this is fully silvered or fully gold mirror, and this is called as, this particular structure is called as, this is the cavity. This is called as the cavity, and this is filled with the active medium. This is filled with the active medium. Filled with the active medium, right? So we got this outer structure as a cavity, and we have fitted that with the two mirrors. One is fully silvered mirror and there is partially silvered mirror. This is filled with the active medium. The active medium may be gas, okay, maybe the solid, okay, maybe liquid. So this is the active medium which is filled inside this, right? So this is the medium, and we have to supply energy to this so that it will excite, it will go to the excited state. So what we need excitation source. We need excitation source. We need, okay, this is the excitation source, and this excitation source may be electrical. That means you might have seen the most of the lasers which we have nowadays, those are using the batteries, small batteries or bigger batteries, right? So we can supply the energy, it needs the energy, right? So here we have this material, and then to excite this to the higher state, okay, this is a ground state, it has to go to the excited state. What we supply the energy, right? The same thing we should supply in the form of electrons or in the form of a light. So electrical energy we are supplying means we are supplying electrons. So we will see that how it works in the next construction. And this is a basic construction schematic diagram. Okay, when we supply energy to this, when we supply the energy to that, so it is going to excite, it will excite, and by exciting, these all will start emitting the light. Okay, these all atoms will start emitting the light. Okay, in all the possible directions it will start emitting. So which all are emitted in this, those will go outside, and which all in this direction, in this horizontal direction, so it will go and hit to this mirror, it comes back. Okay, it will go hit to this and comes back. There are so many rays, there are so many rays, those rays will be interfered. Okay, when it is interfered, we will get the intense light which is coming out from this cavity, that is the laser. Okay, what is happening here? There is interference, there is the interference happening. So this is constructive interference, that is constructive interference will take place. That constructive interference between these horizontal rays that will emit out of the cavity, and we will get the laser. So you may ask why we have this partially silvered mirror. Here we have a fully silvered mirror that will just reflect back all the rays which are there, and it will be fed back to this medium, and these all rays will be interfered and it will come out as a laser. And here also the partially and partially silvered end, so these half of the rays will go back and fed back to the mirror. Again these will go and hit to this mirror and come back while interfering, while going to the mirror. So this light is used as again the source for this medium. While it is coming back to the medium, it is used as a source again for this medium, so that multiple rays, thousands, millions of rays will again enter back to the medium and excite and again come back as a laser. So this is fed back to the medium again and again, and half of the rays will come out as a laser. Every time it is going inside, it is multiplying the excitation. So that is the idea behind using the partially silvered mirror and fully silvered mirrors. So this is the block diagram. Here we have many terms. The cavity is one, okay, in which what is a cavity? It is a space which is occupied by active medium. What is active medium? Active medium is the medium in which the excitation takes place. Okay, and so here we have so many terms. The first term is excitation source, and this excitation source is called as pumping. Okay, what is a pumping action? Pumping action, which is nothing but it takes all the atoms to the higher energy level. Pumping is exciting the atoms to the higher level, that is the excitation source. Okay, next one is a cavity. Cavity is one in which a pair of mirrors are there. One mirror is fully silvered and there is partial silvered filled with the active medium. So these are the terminologies which are used in the production of the laser, and this is a schematic diagram. Here the length L is chosen such a way that this L is chosen in such a way that there should be only constructive interference. Okay, that L is chosen with this equation lambda divided by 2. So what is the lambda? Lambda is the wavelength of the light source. which is coming out, divided by 2, and this is integer. This m is integer. So in this condition only, for this length only, we will have all the interference constructive. Otherwise we will get the destructive interference and we will not get effective laser outcome with this cavity. The requisites of laser system, or we can say the requirements, what are the essential things to produce the laser. The first one is excitation source. As we know, this is essential to excite the atoms from ground state to higher state. So there may be electrical or direct we can supply light. Okay, there are so many examples. So in case of electrical, the solid states things are there, solid state lasers are there. Okay, silicon germanium lasers are there. So in case of the light, where we supply directly as a light, so ruby laser is one which uses directly light and gives us the laser as output. So now the population inversion, so we know this condition has to be there. Without this there will not be production of the laser. That means what, we have to pump it. That means we have to excite the atoms in such a way that there should be number of atoms. That means population of E2 level should be more than the population of E1 level. Okay, there should be active medium. So without this we cannot able to produce the laser. So there should be a container, that we call it as a laser cavity of proper length. These are the requisites for the lasers. Now we will see another interesting thing over here. So with these requisites, so we have the another condition. That condition we have to see now. So we know that population inversion means, why we need population inversion. So simply we have these atoms, so we are supplying energy and these are going to higher state and it is lasing, coming back and it is lasing. So this will not give us the strong laser. So one by one these are going to the higher state and coming back to the lower state, giving us the energy. So these will not give the stronger the energy of the laser. So what should be achieved? We should achieve the population inversion. Okay, in some of the cases it will not be achieved. So these are simply going in the higher state, coming back, simply going to the higher state and coming back. Okay, by this action we will not achieve the population inversion. So we need to achieve this n2 greater than n1, so that millions of atoms are there in the higher state and those are coming to the lower state, and we will get the laser out of this material. So this should happen. To happen this, what we need is n2 is greater than n1. That means we should achieve the population inversion. To achieve the population inversion, we have to create the another state. This state should be stable. How to make it stable? We have to create another state. That state is called as metastable state. That state is called as metastable state. So what is this metastable state? So let us consider this E1 state, E2 state and E3 state. Okay, there are three states I am considering. Okay, whereas this E1 is smaller than E2 and this is smaller than E3. So how we have to draw? So let us consider the two things. This is one and this is another thing. Okay, so that this is E1 and this I'll consider as E3. Okay, so now where the atoms are there? Atoms are here in this E1 state. Okay, when I supply the energy here, okay, these will go and sit to the higher state. So these will go and sit to the higher state over here. Okay, so now we have to create the metastable state. So I'll create the metastable state. How it is created? By just doping the active medium. So we have only one active medium. To that one active medium we have to dope it, or if I have only one kind of a gas, we have to mix the another gas to create this metastable state. So this is called as metastable state. Okay, what is its function? So what all the atoms are going here in the excited state, those will not come back to the ground state. So those will not come back to the ground state, those will transfer to the metastable state, and these will start accumulating one by one. So these will start accumulating one by one in this state, so that there is a population inversion between these two states. So there is a population inversion between 1 and the state 2. Okay, if there are n1 number of atoms here and if there are n2 number of atoms here, then we will easily achieve n2 is greater than n1, and this is the population inversion is achieved, and millions of atoms are come back to the its ground state by emitting the laser. Okay, this is the another condition which is very interesting. So to the main active medium we are adding some other gases, or we are adding some other material to create this extra state, which is called as metastable state. The name itself is saying here, it is called as metastable state. And so when I have only this much, when I have this E1 and this E3 state, only this much state, so this will not stay here. So this is 10 to the power minus 8 seconds. So it is going to stay only for 10 to the power minus 8 seconds, and it will come back to the ground state immediately by emitting a single photon. Okay, but in this metastable state, it is going to stay back there 10 to the power minus 3 seconds to 10 to the power minus 2 seconds. Okay, so this is the longer duration of time. So here it is longer duration of time. So this is the lesser duration of time. So here it is minus 8, minus 10 to the power minus 8 is less, 10 to the power minus 3, 10 to the power minus 2, thus the time is more here. So this state is called as metastable state, and this achievement of this metastable state is very important in the case of production.